myself Ketan Bhavsar, Assistant Professor in LJ Engineering College, Ahmedabad. In today's session, we discuss about practical number 1, which is related to the basic gates and how these basic gates we can implement using the software. So let's see in the depth. So basically, we focus on main 3 softwares: Xilinx, Quartus and Vhdl. Basically, these 3 companies are generally used to design Vlsid kits and softwares. Xilinx company, basically the software called Xilinx. Quartus is the name of software and its company Altera, and Vhdl. As you can see, 80 to 85% market in all over the world is covered by the Xilinx software, and 10 to 12% market is generally covered by the Altera or Quartus software. And the Quartus is mainly used for the education point of view, like in education terms, how we can use a Quartus software. And actually is generally used for when we are dealing with real-time applications, and NASA specifically use Vhdl software or Vhdl FPGA modules in space applications. So today we discuss about the Quartus and how Quartus software is actually work, how we can write the code using Vhdl module, and how you can try to simulate it, you can synthesize it, so we can see in depth. But mainly first we can see there are the different types of gate that we have. Inverter, as you can see, if you provide 1, then answer should be 0, 0 and then 1. Similarly, A, B and C for particular OR gate. Fine, so if A or B anyone will equal to 1, then answer should be 1. And similarly for AND gate. So now as you can see, we already seen this type of the basic gates in semester 3. Now how we can simplify or use the different types of gates, so we see in the depth in Quartus software. So mainly we see first of all the Quartus software. So as you can see, it look like this. I just switch off and switch on it. So mainly you can see it look like this, basically that you can see. Create a new project first of all. Then next you can see the location. What's your project name? Suppose you are designed for the inverter, then inverter underscore logic. Suppose I put this name. Next, okay, dictionary, okay, yes. Okay, no. For the C drive. Next, suppose you have some specific kit, then we have a Cyclone 2 and EP2C8T144C8. So as based on your which type of module you have, which type of FPGA you have, that you have to select. Next, next and finish. So after finishing the module, so you have to wait for a few seconds, and in entity side you can see whatever the name you provide your project, it will be generated near entity side right here. So finally you can see it will generated over here. Fine, now right click on it. And new. And we write down a Vhdl file. So it's a Vhdl file. After that, you have to start writing as per the module you have. library IEEE, use IEEE.std_logic_1164.all. So basically library IEEE, it's like a standard header that you can already see in like C language. We use hash include stdio.h and conio.h. So similarly we have to use a library IEEE because this library header is designed by the IEEE standard. Then we use std_logic_1164 package. So this package is very helpful when we are working or designing for the logic gates. So this package is very helpful when we designing the logic gates like AND gate, OR gate, inverters and any logic gates. Now after declaring the library files, we have to declare the entity. So what exactly the meaning of entity? That entity we have to declare in terms of inputs and outputs. So entity, we have a name inverter_logic is begin, is port for inverter A, input std_logic, C, output std_logic, and entity. Okay, so we finally declare the entity point of view to it here. Now similarly now write down architecture, behavior of inverter logic is begin, C less than or equal to not of A, and behavior. So now we finally completed the code. As you can see, library IEEE use IEEE.std_logic_1164.all. It's basically a library, or you can say that the header files for specific this logic. After that we have to declare the entity. In entity terms we declare the input and outputs. So right now we are planning for the inverter. So for inverter we have basically one input and one output. So A input std_logic and C colon output std_logic, means A is equal to input and C is equal to output. So after declaring the entity, you have to end the entity and start your architecture, means we have to write down a logic. So architecture behavior of inverter_logic is begin. So C less than or equal to not of A. So basically we declare outcome here in terms of a inverter. So now we move ahead. So warning, is it okay if the warning is generated? So you can see your code will be simplified over here, and if you want to see the RTL and schematic view, then we have to go in the netlist viewer and the RTL viewer. So as you can see, it's an inverter logic. Similarly, if you want to see technology map viewer and technology map viewer, so here you can simplify the gates, and we write down the code using Vhdl module and try to simplify it for the inverter logic. Now same way, if you want to see in terms of OR gate, we don't, you can put any name, it's an inverter logic, I just write down here, so no need to change. and C it's like A and B. So let's see. So as you can see, it's inverter. It's look like a same that it's generated here. So as you can see, fine. Similarly, you can just need to change here gates like OR gate and again compile it. See, it's OR gate. So we can write down any logic gates for the two input like NAND gate, NOR gate. So you can write down any gate and you can try to simplify it using this particular software. So here we can work on this type of module, and for generating the waveform, if you want to see the waveform, then you have to click on here, simulation file, then wait for a few seconds because this process is going on. Okay, so for that we have waveform generated file, right click, insert node or bus, node finder, or list, decide, okay, and okay. Then you have to provide the 1 and similarly 1. Then try to simplify it. Okay. Save the file and it will generate it. So as you can see, for 1 1 the answer should be 1, as you can see C1. So if you want to change the input possibility, that you can also change using this particular module, and value it should be low. Yeah, and again you can have to simplify it. So you can see. So we try to simplify it using the waveform 2, and waveform is also play a main role where you want to change the value, change the functionality of the bits, like I just change it right now and try to again simplify it. You can see it's still 1. Now I try to change it for the module, and value low. Okay, again save it. You can see your answer should be 0. So as you can see, based on this truth table, that you can see we have a logic according to that. So we can also simplify it using the simulation too. So I hope you are getting the idea about how we generate the simulation file, how we generate the waveform, and how we can simplify or compile the project in quarters. So I hope that you are getting the idea about this software. If you have any doubt, fine, then you can contact me, and I also generating this same model using the Xilinx software and also try to simplify it. So thank you very much, and if you have any doubt, then you can contact me.